Like a giant dragonfly, this winged monster crawls along the runway. The men inside it are tense, anxious as the machine rolls out for the takeoff. Now comes the big moment. The control tower calls, "Cleared for takeoff." Muscles are tense, minds alert. Here she comes. There are all types of airplanes, from the propeller-driven bomber to the peculiar-looking helicopter, to the newer, faster jet-powered planes. Airplanes are of all sizes, too, ranging from the small private plane to this giant, which can lift its immense weight more than 8 miles above the ground. Passenger planes carry people to and from the far corners of the earth in a few hours. But what is it that enables airplanes weighing hundreds of thousands of pounds to leave the ground? How do planes fly through the air? Let's take a look at a small plane and see what really happens. As an airplane gathers speed, the air rushes faster and faster over the wings. Due to the special shape of the wing, this moving air creates a partial vacuum on the top of the wing. The pressure is now greater underneath the wing, so it pushes upward, lifting the plane into the air. This force, which causes the plane to rise, is called lift. The blades of the airplane propeller are twisted like fan blades so that they bite into the air in the same way a screw bites into wood. This pulls the plane forward. As the plane moves, air rushes over the wings. Because of the shape of the wing, a partial vacuum is created above the wing. The air pressure below the wing pushes up to fill this vacuum. It is this force which lifts the plane into the air. The faster the air moves past the wing, the greater the lifting force will be. As the plane gathers speed, air rushes faster and faster. The vacuum above the wing becomes greater and the lift increases. Although a jet plane has no propeller, it's lifted into the air in exactly the same way. Air enters the jet plane through an opening in the front. It flows through a duct back to the jet engine. The jet engine compresses the air and heats it to a very high temperature. It is then forced out the tail of the plane at tremendous speed. Let's trace the air again. In the front, back to the jet engine where it's heated by the burning fuel, and out the tail in the form of hot exhaust gases. The great force of these hot exhaust gases shooting out the tail pushes the plane forward. Some airplanes have both a jet and a propeller. The propeller to pull, the jet to push, both driven by the same engine. They are called turboprop planes. As this jet plane gathers speed, air rushes faster and faster over the wings. As soon as the lift of the wings is greater than the pull of gravity, the plane rises from the ground. Now we know something about the force that lifts airplanes into the air, but how are they controlled? How do they dive, climb, and turn? Let's go back to our small light plane again. The airplane is controlled by control surfaces, which are located in the tail and at the rear edge of the wing. The rudder is used to steer it right or left. The elevators make it go up or down. The The ailerons are used to tip or bank the plane to either side. The pilot moves these control surfaces by using the controls located in the cockpit. The rudder is moved to right or left by foot pedals. On this plane, the elevators are moved by pushing the wheel forward or back. And the ailerons are moved by turning the wheel. Some airplanes use a stick for controlling elevators and ailerons in much the same manner, but the wheel is more common. Now let's see how these controls affect the plane in flight. In level flight, the controls are in their center or neutral position. When the wheel is pushed forward, the elevators are lowered. The air strikes the lowered elevators and forces the tail of the plane up, causing the plane to dive. A turn requires the use of both rudder and ailerons together. The pilot pushes the right rudder pedal, the rudder swings to the right. At the same time, he turns the wheel to the right. This moves the aileron so that the left wing is raised and the right wing is lowered. The combination of the two controls produces a right turn. Even the very largest airplanes have exactly the same controls as our small plane. The elevators and rudder of this giant plane are so large that the pilot has special machinery to help him move them. Let's watch this giant preparing for flight. First, the engines are started and warmed. Every detail is checked and rechecked. Everything must function perfectly before flight. Everything in readiness, the airplane begins to move slowly, almost clumsily, out to the takeoff runway. Notice that this airplane has its propellers on the back of the wing. Thus, instead of pulling the plane through the air, these propellers push. Now the big plane comes roaring down the runway, its 6 huge engines wide open, 6 big windmills biting into the air, tons of metal rushing forward faster and faster. Smoothly and almost unnoticed, the wheels leave the ground and the gigantic ship is in the air. When you see an airplane flying high overhead, stop and think. Think of the astounding speed of the jet airplane, this plane that flies a mile in 6 seconds, the time it takes you to tie one shoe if you're fast. Think of the enormous size of some of our larger planes. Think of the tremendous lifting power these wings must have to lift this giant into the air. And remember that this lifting power is caused by the air rushing past the specially shaped wings. When the lift of the wings is greater than the pull of gravity, the plane rises into the air. Remember the control surfaces that enable airplanes to dive, climb, and turn. All controlled from within the cockpit by the pilot. Think, too, of the importance of the airplane in our everyday life. Fast, safe transportation to almost any point in the world in a few hours' time. The airplane is constantly being improved. Many planes only a year old are already out of date. For ever since the airplane was first invented, men have been striving to fly faster, higher, and safer than ever before. The the airplane of the future, we know only that it will be faster, better, and safer than the airplane of today.